Hello, welcome to this video on distance time graphs. So we're going to be looking at how you can complete calculations using data from a distance time graph in this video. So just a reminder of your distance speed time calculations, your formulas for these. So these will be important on these. So distance is always, remember, speed times time. Time is always distance divided by speed. And speed is distance divided by time. And you can use your formula triangles to help with this. Okay, so I'm just going to show you an example of a distance time graph first, just to sort of make it clear, obviously, what you can expect from these. So we've got this example here, which shows you Sian's journey from her house to the shops and back. So you will notice that it's starting at 0, and the line is going up to 20 kilometers. So that shows you that our house is 20 kilometers, this point here, because if we read it up from 30 at the bottom, we're going up to 20. And the 30 at the bottom shows you that it's taken her half an hour to get to the shops. Now, when you get a horizontal line from left to right, that indicates that she's not moving. So she's stationary, essentially. She's not moving at all if she's horizontal. Then if it goes down, that shows you she's going back home. She's going back to where she started from. Okay, so if you ever see the line going back down again, it means they're going back the way that they started from, the way that they came. A few things you could pick out from this graph. Well, she's done 20 kilometers in 30 minutes. So you could double that. So 20 times 2 is 40, and that would give you her speed. Because if she's done 20 kilometers in half an hour, that means her speed got to be 40 kilometers per hour. So you can pick out information like that from them. You can also tell that she's a little bit faster on the way home because she's only taken 15 minutes to get home. All right, so here she's done 20 kilometers in 15 minutes. So perhaps there was less traffic going home there. So you can do a couple of things with that. You can do 20 times 4, which means she's doing 80 kilometers an hour because there's 4 15 minutes in there. Or you can do 20 divided by 0.5 because 15 minutes is a quarter of an hour. And that would get you your speed as well, which is 80 kilometers an hour. So sometimes they ask you to do that. They might ask you to compare different parts of the journey. And the key thing is if the line's steeper, as it is on this part of the journey, that means the speed is faster, essentially. If the line's not as steep, it's a little bit slower. Okay, so let's have a look at a question on this then. So Rebecca's gone on a bike ride. We've got this graph showing the distance from home on her bike ride. We've got 3 questions here. So we want to know how far she's travelled after 30 minutes, how long did she stop for a rest, and how far did she travel in total? Okay, first question then, we want to know how far she went after 30 minutes. Well, that's going to be 6 kilometers. And the reason it's 6 kilometers, because if we go to 30 minutes and we follow the line up, we can see here that line is meeting the distance at 6 kilometers. So second question, you notice that there's 2 squares where it's horizontal. And if we look between sort of 60 and 90 here, well, there's 3 squares. So every square essentially here is, I'll do it down here. Every square is 10 minutes on here. We've got 2 squares, so that's going to be 20 minutes because 10 times 2 gives you 20. Okay, so we're looking for how far she travelled in total here. So she's gone 12 kilometers on her journey. She stopped and she's going back to exactly the same point. And because we're going back to 0, we know that she's doing the same 12-kilometer journey twice. So that will give her 24 kilometers. Okay, slightly tricky, slightly trickier example here, because you've got much smaller squares. Now, what I would always advise you to do on these questions is have a look at how many squares you've got. So between 0 and 10, we do have 10 squares. So one small square on your distance is going to be 1 mile. So always try and work out what one small square is. And then between 2 and 230, we've got another 10 squares there. So that's going to be 30 minutes divided by 10. So every square there is going to be 3 minutes along the time. That's quite useful on some of the trickier questions. Okay, I've got 2 questions then for this distance time graph. So Emily's gone to the beach, she stayed there, then she's gone back home. We want to know how many minutes did she stay at the beach? And then what was her average speed on the journey to the beach? Okay, so let's have a look at this then. So she stayed there for 75 minutes. And the reason it's 75 minutes is because here is 2:45. It's exactly halfway between 2:30 and 3 o'clock. And then she stopped there till 4 o'clock. So we've got an hour and a quarter, so 1 hour, 15 minutes. And they did specify that they wanted the answers in minutes there. So that would be 75 minutes. Okay, so for this final question then, slightly trickier this one was. I asked you to do the average speed on her journey to the beach. Well, she's going 35 miles in 45 minutes here. So you can see that here because we're going from 2 o'clock to 2:45. So that's your 45 minutes, and then that meets the distance at 35 miles. Now 45 minutes, if you write 45 over 60, that is 0.75, so it's 3/4 of an hour essentially. So remember, you're doing distance divided by time. So 35 divided by 0.75 is 46.6 miles per hour, which I think is acceptable here. So round that to 47 miles per hour. Okay, so just be really careful with your decimal time on questions like this. They're usually quite nice and they give you, reasonable numbers most of the time. But if they don't, just write the number of minutes over 60, divide that by 60, and that will give you the minutes in hours if you do need that on perhaps a more complicated question. Okay, thanks very much for listening. So please stay tuned for some more Maths Wizard videos.